All right. All right, let's get to it. These take a while. So our first example is here. X minus 4y. These take a long time, by the way. So when you get your assignments and you see that there's only like 2 or 3 or 4 problems, then don't be surprised by that, okay? I'll give you a moment. I'm going to make sure I copied mine down correctly. You make sure you're copying yours down correctly, because we'd hate to start the week on a silly note like that. So if we were doing this the way we did it last week, what would we be attracted to? These. Absolutely. So we have to ignore that now. All right. Our goal here, um, let me make a new page and I want you to just find some other spot in your notes and I want you to write this down. Every time we do one of these problems, we're going to have a goal. And as we work and you start to understand the process, the how do I do this, you'll understand, I think, more clearly how to get to the goal. The first 20 minutes or 15 minutes of this, you're probably going to feel pretty clunky, kind of lost a little bit. But the goal is to make this, and I'll show you more about what this means. That is a sign for what we call a matrix. It is not a tall vertical bar. It is a bar with horizontal notches in it. So whenever you see someone make a notch, a symbol like this, they're about to write a matrix. And a matrix is just a rectangular arrangement of elements of numbers, okay? And our goal when we're done is to make a matrix that looks like this. This is what we call row reduced echelon form. When you have ones going in the diagonal in those exact locations, starting in the upper left corner, working your way to the lower right, that is a row reduced matrix. Our goal is to get the matrix that we're about to go write, the one that I'm about to write on the other page. Our goal is to get the matrix we're about to create to look like this. And there's steps. It's a process. This isn't one of those kind of do your own thing, it's up to you kind of processes. It's very structured, regimented. On the other side, there will be an augmented matrix. This one is a vertical bar. It does not have any notches on it. And on the other side of it will be 3 numbers. And then we will close off the full matrix like this. So what you have here is 2 matrices. One of them is a 3 by 3. So this is a 3 by 3. I always remembered as a kid when I wanted to remember which one designates rows and which one designates columns. Back when I was younger, there was something, I don't even know if it still exists. There was a type of beverage, a canned soda called RC Cola. Do they still make that?
Oh yeah.
That's how I always remembered which number designates rows and which number designates columns. So RC Cola, rows, then columns. Got it? Which with a 3 by 3, you could get those confused because there's 3 rows and 3 columns. But having said that, the row reduced matrix is a 3 by 3. Having said that, do you know what size matrix that augmented one is? Is it a 1 by 3 or a 3 by 1? How many rows does it have? 3. How many columns does it have?
One.
1. So this is called a 3 by 1. Okay, so just remember RC COLA, rows come before columns, okay? So when I go back to the other page here in a second, I'm going to show you what we're going to do is we're going to take the numbers out of the system and we're going to write an augmented matrix that represents the system. And then we're going to get into the brutal part, which is creating the row reduction, working it down to look like the number that's on the TV right now. Okay, and I'll flash back to this periodically just to remind you that this is our goal. And the order in which you make this happen, it's imperative that you not go rogue. All right. You have to place a one in a certain spot first. Well, more to the point, no. You have to place zeros in these two spots first, and then you place the zeros in these two spots second, and then you place the zeros into these two spots last. If you do it in any other order, then any work you've done prior to whatever you're doing will be messed up and you'll have to go back and start over. Okay. So column 1 gets fixed first. Column 2 will get fixed second. Column 3 will get fixed last. Good. All right. And then we'll take a look at what this means when we achieve our goal 12, 15 minutes from now. Okay. Cool. So what we're going to do is we're going to take this system and we're going to write it as an augmented matrix. And it's going to be a matter of just pulling the numbers out. We're basically going to take the X's, Y's, and Z's and make them go bye-bye. So we're going to create a matrix with only the numbers that you see. So for the first row, for example, what number's in front of the X? 1. So I'm going to make a matrix setup and I'm going to put 1, -4, 1, and 23. Okay. And then for the second row, what am I going to write? 5, 6, -1, and 7. Okay. Again, these are called the coefficients. You've known that word for years. We don't use it a lot, but in equations or in algebra, the numbers that are in front of variables are called coefficients. So we're just going in and prying the coefficients off of the terms and building a matrix out of just them. And then the final row is going to be -3, 3, 1, and -22. So this is the part now where you kind of say goodbye to your friends and tell them you'll say, catch you on the flip side. I'll see you in 15 minutes or so. So we're going to dive in now and we're going to work just with the numerical matrix, the coefficient matrix like this. Any questions other than what in the world is going on? Any questions about that so far? What's that? Because there were terms that didn't have numbers with them. So like there's a 1 in front of the X, a 1 in front of Z, a -1, and no problem. That's why I cross my Z's. Yeah, a lot of people learn through doing algebra courses that crossing your Z's is actually not all that much of an oddity. It helps them to not look like 2's, just FYI. I don't really have a good reason for why I cross my 7's. I could probably make one up. I think it might just be more of a habit, but crossing Z's is for a reason, so they don't look like 2's. You think my Z's look cool? Yeah. They just look radder, more ratted. Super rad. Okay, so now we begin the thing that we do. We're going to utilize row operations, and you're going to hear me use this terminology a lot. I'm going to refer to the number 1 as the worker bee. I used this vocabulary starting last year, and they were using the vocabulary back at me a lot, and I thought, well, if they're going to use it back, then it must be sinking in. What I mean by this is 1 is not going to get altered. 1 is going to be the guy that sort of kind of chameleon modifies himself behind the scenes to create destruction below him. The goal here is to make the 5 and the -3 below him go away. So I'm going to write this down, and then before you write it down, let's talk about why I'm saying this. Okay, we're going to take -5 row ones plus row two, and then we're going to take 3 row ones plus row three. And again, I don't want you to write that down until we've had a chance to discuss why in the world would I do that. So let's talk about that one that I circled in purple. If I multiply him by -5, what do I get? If I multiply the 1 by -5, what do I get? -5. And if I add that to the number right below it, what do I get? Mission accomplished. 0. Anything else that happens in this step with all of the other numbers in the matrix, I'm not interested in that. Okay, I'm only interested in my objective. And my objective is, I'm going to go back to the other page now, to make those yellow zeros. Anything else is collateral damage. I shouldn't even say damage, it's just a trade-off. And then if we talk about the second row operation, if I take the number that's circled in purple and I multiply it by 3, what do I get? 3. And if I add it to the number 2 below it, what do I get? Mission accomplished. And notice that I'm writing the row operations next to where the result of the row operations will be. I haven't written anything next to row 1 because I don't want to mess with the worker bees row. I want to leave row 1 untouched. Having said that, you would be wise throughout the next few days to take your worker bee row and before you even start, copy it down. This will be your reminder to yourself that that row, while we're using it to perform calculations, we're not actually modifying as we go. So for the first time ever, let's dive in. And let's take -5 times everything in the top row plus everything in the middle row. So I'm going to draw little boxes and kind of delete them as I go. Inside this yellow box, if I multiply the top number by -5 and add the one below it, what do I get? Correct. So our first 0 is placed. 1 down, 5 to go. Now we're going to finish this calculation throughout the entire row 1, row 2. Okay. Thank you. So now we're going to take and we're going to move over, and I'm going to move my yellow box over to here now. So we're performing the same operation on the two numbers in the yellow box. And the operation doesn't change. We're taking -5 times the high one plus an unmodified middle one. So what's -5 times the top? 20 plus the middle? 26. So we're going to place a 26 here. Got it? I'm going to relocate my yellow box. And even though it's so tempting, we just want to add those together. Like, can't I just, nope, you're not allowed to. We're performing the same consistent operation throughout that will place a 0 in the one place that we need to place it first. So take -5 times the top number. What do you get? You get -5. Thank you for whispering that at me. And then when you add that -5 to the -1, what do you get? Correct. And so we've now placed a -6. And we have to perform the same operation consistently throughout the entire left to right. Okay, and so now we're going to take -5 times the top. What's -5 times the top number? 112. It's -115. If you were typing this into your calculator, which you're going to use a lot, you would type it in as -5 times the top number plus the unmodified number below. Okay. So that's -115 plus 7, which is -108. So we've done essentially 1/6 now of our mission. Okay, we've placed 1 0 with a whole bunch of other stuff that just kind of effectively came along for the ride. Any questions about that? You can see how if you're someone who's prone to making little mistakes, this could be a bit on the frustrating side. So let's be real cautious with our calculations. All right, we're on to the second 0. So we now embark on the second of 6 steps. And our job now is to place the 0. I don't know if I meant to delete this box every time. Excuse me, folks. Ooh, good thing I have a tiny little eraser, huh? Whee. Our job now is to place a 0 here, where I just put a gold box. You understand? And so we already have our row operation defined. We know what to do. We knew what to do going in. We're going to triple the top and add the bottom, right? So it's going to be harder for me to do boxes this time. My purple is still my worker bee. He's using himself for every calculation that we do. So the gold box won't work this time because I have, bless you, because I have Splitsville, right? I'm going top to bottom. So triple the top. What do you get? 3. Add the bottom, -3. What do you get? Mission accomplished. So we have now accomplished placing 2 of our zeros, but now we have to ride this out. There's still 3 more calculations that we have to do subsequent to that. Okay, so don't pat yourself on the back when you make a 0 because you still got a lot of other steps to do. All right, so triple the top plus the bottom. I'll point to them here. Triple that, add that. Got it? What do you get? It's -9. If you triple the top, it's -12. Add the bottom, -12 plus 3 is -9. Triple the top plus the bottom. Triple the 1, what do you get? 3, add the bottom 1, you get 4. Good, good. And then we got to keep going. We got to triple the top and add the bottom. I hate this problem already, by the way. I should have checked this problem much better. We're going to get some nasty numbers, just FYI. It's like teaching someone to swim by just picking them up and chucking them into the 12-foot section of the pool and saying, good luck, suckers. So yeah, settle in, put your seatbelts on. So if we triple the top, 3 times 23 is 69. Add the bottom, -22. What is 69 plus -22? It is 47. Yeah, this is going to be rough. I, I'm usually pretty good about getting problems and working them out. So I can kind of run interference pre-lesson. This one, I just YOLO'd it. Nah, I'm paying the price. Well, you don't see it yet. Yeah, but we're gonna feel the burn. So one thing I can tell you is this, and this is like a bonus step, is that you should look for opportunities 100% of the time to make your life easier by making numbers smaller. Having said that, take a look at this second row. What do you notice? Yes, meaning that they can all be divided by 2. Good. So what we're going to do here, and this is going to be a little bit annoying, is we're not going to show any row operations here. We're just simply going to recopy the matrix. Trust me, it's worth it. I mean, this problem is going to kind of suck either way, but it's going to have a little bit less suckitude if we make one of the rows half as big. So the top row and the bottom row, I can't really do anything with. Because the 9, 4, and the 47 can't all be divided. The 4 and the 23 again are relatively prime, but the middle one I can knock it down. Half as big is twice as good, right? So I have a 0 and then a half 26 and then a half -6 and then a half -108. Got it? How are we 1/3 of the way home? Yes, if I go back to my other page, we have accomplished our first objective. The yellow box is check, check, done. We placed zeros, we're good to go. Now we're on to the red zeros. And what we're going to do this time is we're going to change and we're going to now rename a new worker bee. My worker bee is now the number 13. Got it. I want you to understand now that the middle number becomes the worker bee, and he's going to be involved in operations that work upwards to destroy the -4 and downwards to destroy the -9. I'll go back to the other page again. Look at those red zeros where they are. They're above him and below him. So he is the worker bee row, which means that he shall remain unmodified. So I'm going to leave a little bit of a space here. And I understand that I have the benefit of being able to keep scrolling sideways. You're limited by a piece of paper where you have to kind of zigzag. And we did these in college. I took a class in college called elementary linear algebra. There was nothing elementary about it, but we would solve these, and they would take one problem would literally take like the front and the back of a piece of paper. So it's a lot of work, and then zigzag, work, zigzag, so you find yourself constantly rebuilding as you go. So just if you think this is taking a while, yeah, it does. But again, I have the benefit I can just keep going sideways. I've never pressed my luck and seen how far I can go, but I'm just going to go till it tells me I can't. So notice I left a space. I'm going to take the worker bee row and I'm going to copy him over. So I'm going to have 0, 13, -3. And then the augmented side, I'm going to have my -54. And then I'm going to shut the matrix like this. So can any of you clever little dogs give me a row operation that must involve the worker bee, row 2, that will make a 0 right there? Nothing else matters. What would my row operation be? Plus, no. I thought you were onto it there when you said it. I'm going to give you a moment. Think about this. We're going to utilize the purple number and the number right above it. You've done this before. Hundreds of times have you done this, just maybe not in this, uh, from this point of view, but you know how to make a 13 and a -4 create death. How? Yes. So what will my row operation be? Yes. So I'm going to do it in a different order. I always like to put my worker bee row first. When I do my R1, R2, R3 declarations, I always like worker bee first. It's how I am. I think you'll find it to also be good. And notice when I write this, I'm going to write it next to where the result will go, not next to the worker bee. Next to the worker bee row should always be a vast emptiness. So up here, I'm going to write 4 middle rows, so 4 R2s plus 13 R1s. Nice. Now let's employ that same thinking again. Good work, everybody. Let's take that same thinking and ask ourselves, how can we make that -9 take a dirt nap? Well, again, you know how to do this. You understand the dynamic. How can you utilize a 13 and a -9 to create zeroness? Again, this will work. Listen, if it was a 4 and a 6, we wouldn't be saying multiply them by each other. We would turn them into 12s in our head. But we understand that 9 and 13, I mean, you have to make them both into 117. Like the only way with these ugly numbers, it's why this problem should have been vetted well, is to multiply them by each other. So what's that row operation going to look like?
9 R2.
9 R2s plus, there you go. Take great care again to note that you're writing the row operation declaration next to where the result will go with that empty space next to the worker bee row. That's critical. All right, we're gonna need some calculators, I'm guessing. So I'm gonna do, not that I don't trust you guys, but we as humans tend to do funny things. So if the more of us that have calculators out, the better. And if you're a part of the process, you'll learn more because you'll get in the flow of how to type this in. So here we go. Just recite it in your head. I'm taking 4 middles plus 13 tops. 4 middles plus 13 tops. 4 middles plus 13 tops. Let's begin right here. I'm taking 4 middles and I'm adding 13 tops. You don't need a calculator for this one. What's 4 times 0? What's 13 times 1? 13. So my 1 has been ruined and now is a 13. That's okay. What you can't afford to ruin are the zeros. The ones, there is a way to protect them, but this particular problem does not lend itself to this. When I was a younger teacher, I'm just going to show you this real quick. I would require my students to turn this 13 into a 1, the one where I'm moving my pen right here. Do you see it? That would mean that we would have to divide this whole row by 13. Teachers, we get better as we get older and we hang out and we do this a lot. And when I was younger, I was kind of stupid. So like I told my students, let's make a 1. And so they did 13 divided by 13 and got 1. But then -3, they divided by 13 and got -3/13. And then they took -54 and divided it by 13. And you guessed it, they got -54/13. I was not very smart in how I approached it. And so I'm happy to report that there is a better way. The trade-off to avoid fractions is yes, we can avoid fractions, but we have to then work with really big numbers, which I think that's a fair trade-off. So we don't want to do this. There. Okay, so we're back. 4 middles plus 13 tops. I already know this one and I don't need a calculator for it. Now hold your horses there. Slow your roll there, homie. Inside this purple box, don't we already know what that answer is going to be? What's 4 middles? Don't care. What's 13 tops? Don't care. All I know is that they're going to be a positive number and a negative number that are the same number, resulting in definitively a 0 right where we want it. 4 times 13, by the way, is 52. And -4 times 13 is -52. But I got my 0. Back we are. 4 middles plus 13 tops. What's 4 times -3? Don't say 12. Stuff like that will kill us. It is -12. And what's 13 times 1? 13. And what's -12 plus 13 is 1. And this is where it gets to be a little obnoxious, but I mean, when things are meant to work, they're going to work. And you'll appreciate having a calculator, but you'll also appreciate the way things happen here. So we're all going to take our calculators and we're going to type in the following thing. We're going to do 4 times -54 plus 13 times 23. That's 4 middles plus 13 tops. And you all should be getting the same number. What is it? 4 middles plus 13 tops. Say it again. 82. Correct. Okay. I can't believe I thought we'd get through 2 of these today. We're going to be lucky if we get through 1. No, we're going to get through 1. We're not leaving this room until we get through this problem. So that's a lie. If the bell rings, we have to leave. But you know what I'm saying? Just talking tough. All right. So we have a 0. Woo. And now we have to do the bottom red row operation, which says to take 9 middles plus 13 bottoms. 9 middles plus 13 bottoms. 9 times 0? 0. 13 times 0? 0. Surprise, surprise. And this is happening. Protecting our zeros isn't something that we get lucky. We do these in the right order. Our zeros will stay safe. If you ever lose a 0, then you're gone. Something terrible has gone wrong if you lose a 0. Those are your prized possessions in these problems. All right. 9 times this is 117. 13 times this is -117. Surprise, surprise. We get exactly what we knew we were going to get. The whole reason we're doing what we're doing is to get that zero right there. The next operation that we're going to type into our calculators is 9 times the middle number, -3.
-9.
Uh, where you at there, buddy?
No, because you wanted to cancel.
Right. This one that I'm circling in purple is a positive. This one that I'm circling in purple is a negative. So we don't have to do any signs. So we're now going to type in 9 times -3 plus 13 times the bottom, which is +4, which is 25. So that means we're going to place a 25 right here. Rinse and repeat. And again, it feels like this gets out of hand, but the numbers will generally, they get big, but they kind of control themselves. There's a little bit of like self-policing going on behind the scenes here. So the next thing we're going to type in, and this is totally a calculator appropriate problem, is we're going to do 9 times the middle, which is -54, plus 13 times the bottom, which is 47. And I'm going to type this one in with you. So 9 times -54 plus 13 times 47. Just let your calculator do it all at once. And I see the number 125. We are 2/3 of the way home. I would ask if you have any questions, but the bottom line is you're probably feeling a little overwhelmed by the process. Do you see any gifties that we can take? Every time you complete a double zero pack, you should stop, pause, and ask yourself, is any row or rows begging to me to make them smaller? What do you see, Will?
The bottom row. By 20.
It can be divided by 25. You're not wrong. It could be divided by 5, but let's take the really big step here. Because again, the smaller I can make my numbers, the better. So I'm going to take this bottom row, and you're going to do it too. And I'm not going to show a row operation this time. I'm going to copy down the top row. And I'm going to copy down the middle row. There's nothing I can do with the numbers in those rows. They're just not playing nice. I say I picked a whale of a first problem for us to do. 13s and 54s and 83s, like, bleh. But the bottom row is calling to us. And by the way, as you'll come to appreciate, when you're doing this someday, like on an assignment tomorrow or on a quiz someday, a week from now or whatever, this will feel good. The fact that these two numbers in this red box can both be divided by 25 can't mean anything that's not good. That's got to make you think I'm doing something right. And so this is going to become a 0, a 0, a 1, and a 5. And do you want to take a shot? Which number am I going to circle in purple and call our worker B? Right there. Boom. By using him as your worker bee, you are guaranteed to preserve the zeros that you've already created. Those 4 zeros that you see on the board right now are precious prized possessions. So to make the 3 directly above him become a 0, what's the row operation? 3 bottoms plus unmodified middle. And to make the 1 way up here where I'm wiggling my pen around in a circle, how do I make that go away? Do not use subtraction, okay? Trust me on this. I like the opposite of row 3 plus unmodified row 1. If I perform these 2 final row operations, my quest should be complete. We're going to always copy over worker B row. So we're going to have 0, 0, 1, 5. And now on our final leg of the journey, let's go. Because the clock's telling me I have 5 minutes and I need 6. So let's do this. So let's start by tripling bottom. So just say it in your head. Triple bottom plus the middle. Triple bottom plus the middle. Triple bottom plus the middle. Triple bottom plus the middle is 0. Triple 0 plus 13 is 13. Triple 1 plus, that's 3 plus -3 is 0. Triple 5 is 15. 15 plus negative 24 is triple 5 plus negative 54 is 15 minus 54, which is negative 39. Huge. Last leg of the journey is the opposite of the bottom. Saying these things, it's hard to take this quiz. Sometimes when people are doing homework, I hear a lot of people, it sounds like a bunch of psychopaths talking to themselves. Opposite of the bottom plus the top, opposite bottom plus the top, opposite bottom plus the top. You just keep repeating it to yourself so it gets stuck in your head. Opposite bottom plus the top, 13. Opposite bottom plus the top, 0. Opposite bottom plus the top. Mission complete. One calculation left. Opposite bottom, negative 5, plus the top is 78. We're done. Now, I told you on the other page that our goal was to get a matrix that had ones. That's where I kind of lied to you, because forcing ones along the way is where I showed you this about 8 or 9 or 10 minutes ago, or maybe, I don't know, 6, 7 minutes ago. Sorry. That by making ones along the way, you're forced to divide and create fractions. So instead, I want to now reveal to you what in the world just happened. Well, here it is. When we started this problem, what letter was attached to that 13? So this equation says 13x equals 78. Because how many y's are there? None. How many z's are there? None. Divide both sides of this by 13. You now know that x equals 6. Done. Take a look at the middle row. There are no x's and there are no z's. What will the equation say? 13y equals negative 39. Divide both sides by 13. What does y equal? Negative 3. And when I hear you guys casually saying 3, I can't reiterate enough. You have got to hold yourself accountable for everything. And I know oftentimes people go, well, that's what I meant. Well, say what you mean. Every sign. Can you imagine how impossible these problems are if anywhere along the line you drop a negative? And then the bottom row, there are no x's, no y's, and just one z, which equals 5. So our answer is 6, negative 3, 5. Scale of 1 to 10. 1, I have no idea what just happened. 10, that was the easiest thing I've ever done. Where are we? Right in the middle? 5 is a good outcome for that. I'll take it. I think I don't know what I'm going to do with this assignment. I'm going to keep kind of grinding through some problems and see if, from my perspective, if they're good for you guys or if they're just going to frustrate you. But obviously, despite what Canvas says, I'll modify it. I'm not handing out anything today. I feel like if we got through that and you feel like you're a 5, I'm going to call that a win. I'm going to call that a December 8th victory for all of us, okay? If you don't feel blown out of the water by that. So, great job.